Hello dear students, welcome to my channel. Today we are going to discuss the hydrocarbon toluene and the chemical properties method of preparation of the toluene. So let's talk about the interesting fact about the toluene. Subscribe the channel right now. First you have to understand how this word comes from. The toluene. Toluene was obtained by the dry distillation of tolu balsam, tolu balsam, and it is also known as toluol. Also we call it toluol. Okay, so let's start the method of preparation now. Method of preparation of toluene. Let's discuss that. So first method is very easy one, from light oil fraction of coal tar. From light oil fraction of coal tar. So it contains mainly benzene, toluene, xylene, and etc. So by fractional distillation, we can separate it, and at toluene will be separated at 110 degrees Celsius in this fractional distillation. So the process is fractional distillation. The second important process is from petroleum. In this case, what it will be, we have to take N-heptane. Okay, N-heptane, that could be like CH3, CH2, H. So this is nothing but a N-heptane in another way. We are making it Cr2O3, L2O3 at 600 degrees Celsius. We give methyl cyclohexane, and further it will convert to, by raising of 3 hydrogen gas molecules, CH3. So N-heptane can be converted into toluene. The next very important reaction is from Friedel-Crafts reaction. In this method, the benzene is treated with haloforms in the presence of anhydrous HCl3. It will form toluene. Toluene plus HX will be removed. The next reaction we are going to discuss is Wurtz-Fittig. After Friedel-Crafts, the Wurtz-Fittig reaction. In this reaction, the bromobenzene, basically 2, is split with 2 moles of Na plus bromomethane in the presence of ether heating up will give toluene plus 2 moles of NaBr. Okay, this is another method known as Wurtz-Fittig. The next method we are going to discuss by the reduction of benzaldehyde. by the reduction of benzaldehyde. In this method, we have to reduce the benzaldehyde into toluene. It means aldehyde into alkane. Let's discuss that. So we have a benzaldehyde here, CHO, is reduced for in the presence of ZnHg, HCl gives toluene, gives toluene plus water molecule. The next method is from toluidine. In this method, we have toluidine. This is CH3. Since it is toluidine, so it is NH2. In the presence of dry NaNO2, HCl, it will give CH3 and double bond N. After treating with alcohol, it forms toluene plus N2 gas plus ethanol plus HCl. So this is the reaction in which toluidine reacts with dry NaNO2, then in the presence of alcohol. This one is first, second is okay. Sorry for the disturbance. The next method is from cresol. Cresol, you must have heard about it, cresol. So we can make the cresol now. This is CH3 here or OH. Okay. So it is basically 2-methyl phenol treated with zinc dust. Treated with zinc dust. Heating up will give toluene plus ZnO. So this is the easiest method, cresol, from converting cresol into toluene. The next is from toluene sulfonic acid. Toluene sulfonic acid. In this method of toluene sulfonic acid, this is toluene. So sulfonic acid in this, here it is CH3, and the next is here HO, SO3H. Okay. So now the reaction proceed like that. This is the easiest reaction you are ever studied. In the water, treatment with water, heating up will give toluene plus H2SO4 acid. Okay, so the easiest reaction, you can go through it. The next is from Grignard reagent. You can also prepare toluene Grignard reagent. The reaction goes like that: C6H5MgX, okay, is treated with haloform CH3X, will give C6H5CH3 plus MgX2. Let's write down the example of this reaction. Suppose this is MgCl is treated with CH3Cl, gives toluene plus MgCl2. So this is the reaction. And the last preparation method. So let's discuss the last method, which is decarboxylation sodium toluene. That is decarboxylation of sodium toluene. In this method, we have sodium toluate. This is like that. This is sodium toluate. Okay. Here says it's H5, you must understand. Reacts with NOH to give, in the presence of soda lime CaO, to give C6H5CH3, that is toluene, plus Na2CO3. So when C6H5CH3COO reacts with NaOH soda lime CaO, it will give C6H5CH3. Let's recall all the methods one by one. Okay. The first reaction I have discussed is from lime fraction of coal tar. Coal tar consists of benzene, toluene, xylene. Okay. And in this method, at 110 degrees Celsius, during the fractional distillation, we obtain the toluene. The second is petroleum, in which an heptane convert to toluene in the presence of Cr2O3, L2O3. Third is Friedel-Crafts when treated with haloform. Okay. It will produce toluene. The fourth is voting. The fifth is toluidine method. Sixth, cresol. Seventh from toluene sulfonic acid. Eighth from Grignard, and ninth one, decarboxylation of sodium toluene. So these are the methods, and very important to remember for toluene perspective. And I'm going to discuss the physical properties. Physical properties of toluene. As toluene is a colorless liquid. It is colorless liquid. Its boiling point, we already discussed about it. Boiling point is 111 degrees Celsius. It is immiscible in water. It is immiscible in water. And it is used as a solvent and also in the synthesis of compounds. So it is used as a solvent. So that's all for today. Thanks for also in the synthesis of compounds.